Hello everyone. We can use a scatter plot to look for a pattern in the relationship between two quantitative variables. We can calculate a correlation coefficient to quantify the strength and the direction of a linear relationship between these two quantitative variables. These are the aims of the lecture. The strength of the relationship is determined by the closeness of the points to a straight line. The direction of the is determined by whether one variable generally increases or generally decreases when the other variable increases. A correlation describes only a linear relationship. Therefore, it is important to always do a scatter plot before calculating a correlation. A correlation coefficient is always between -1 and 1. Its value does not depend on the units of measurement. A diagonal value shows the correlation of a variable with itself. So it's always 1. An off-diagonal value shows the correlation between two variables. The correlation of x and y is equal to the correlation of y and x. So it is a symmetrical matrix. The magnitude of the correlation indicates the strength of the relationship. The correlation of 0.7 is stronger than the correlation of 0.3. No, a correlation of +1 and a correlation of -1 have the same strength. A correlation of either positive or -1 indicates that there is a perfect linear relationship and all data points fall on the same straight line. The sign of the correlation indicates the direction of the relationship. A positive correlation indicates that the two variables tend to increase together. The negative correlation indicates that when one variable is increases, the other is likely to decrease. A correlation of 0 indicates that the best straight line through the data is exactly horizontal. So knowing the value of x does not change the predicted value of y and vice versa. We can visualize the strength of a correlation as a skateboard for a strong correlation, a football for a medium or moderate correlation, or a basketball for no correlation. The Anscombe's quartet was developed by statistician Francis Anscombe in 1973 to demonstrate both the importance of plotting data before analyzing it and the effect of outliers and other influential observations on statistical properties. It comprises 4 datasets, each containing 11 XY pairs. These 4 datasets have the same descriptive statistics and a correlation of 0.816. For each of these 4 datasets, determine whether this correlation coefficient is correctly measure the relationship between X and Y. Yes, the relationship between X and Y is linear. No, the relationship between X and Y is not linear. No, there is an outliers. No, there are 2 groups. There are several types of correlation coefficients. The most common type is the Pearson's correlation. When a word correlation is used, it usually means the Pearson's correlation. A Pearson correlation between 2 variables x and y is the covariance of x and y divided by the standard deviation of x and standard deviation of y. The covariance of x and y is a correlation coefficient has no unit of measurements. If the covariance between x and y is A, what is the covariance between y and x? The covariance between y and x is also A. What is the covariance between x and x? The covariance between x and x is the variance of x. If the correlation between A and B is 0.5 and the correlation between B and C is 0.8, can we calculate the correlation between A and C? No, because the correlation between A and C is not equal to the correlation of A and B plus the correlation of B and C. Correlation coefficients are not additive, so we cannot add them up. We calculate a correlation from a sample. However, we are interested in the correlation in the population. The value of a correlation coefficient does not tell you whether it is significantly different from 0. A large correlation could be non-significant and a small correlation could be significant. We have to do a hypothesis test to determine whether the true population correlation is equal to 0 or not. The null hypothesis where rho is the population correlation. If the population correlation is 0, we can use the student t-distribution to do hypothesis testing because the distribution of sample correlation is symmetric and approximately normal. Why is the degree of freedom is n minus 2 and not n minus 1? Because we have two variables, x and y, so we have to estimate two population means, mu x and mu y. Let's see an example. We can use this matrix to calculate the correlation of height between students and their dads. The covariance matrix contains the variance of the student height, the variance of the dad's height, and the covariance between these two heights. The correlation coefficients. Remember, standard deviation is the square root of the variance. For hypothesis testing, the null hypothesis is, and the alternative hypothesis is, we need to calculate the t-statistics. First, we need to calculate the standard error of the correlation. The correlation coefficient is 0.438 and the number of observation n is 198. The t-statistics with the degree of freedom this is a two-tailed test. So the p-value if we use 5% significant levels, the p-value is less than 5%. Hence, we have sufficient evidence to reject the null hypothesis. We can conclude that height of students and their dads has a significant positive correlation of 0.438 at the 5% significance level. Now, can you do this?